All right, in Article 1.3, we want to begin our discussion on scalars and vectors. And this is a very important section of the text. So you do want to make sure you understand this. It'll take several sessions for us to get through all this. So we really deal with two types of quantities in mechanics, scalars and vectors. Now, scalar quantities are quantities that really only have a magnitude that is associated with them. So this would be something like time or volume, energy, speed. We tend to think about speed as a vector, but it's really not. Your speed really just tells you how fast you're moving. It doesn't tell you where you're going. Temperature, mass, how much material you have, and then density. So these are quantities that can really only be referred to with a number that deals with the magnitude or the size of the object. Now, a vector, on the other hand, has both a magnitude and a direction. So some examples of vectors are displacement. So this would be not only how far you move, but this would also be where you went. So this would have both a magnitude and a direction. Velocity. This is really the vector part of speed. So this would have not only how fast are you going, but in what direction. Acceleration is a vector. It is the rate of change of velocity, but it has a direction associated with it. If you're speeding up, then your acceleration vector could be or would be in the same direction as your velocity vector, but you could also be executing a turn, in which case acceleration has a component perpendicular to your velocity vector because it has to rotate that vector. Torque is another example. Another word for torque is moment. So this is a rotation type or the action of a force through a distance. A force is obviously a vector. This is going to be one of the major vectors that we look at. The other major vector that we look at is moment or torque. And then momentum. Momentum is a mass times a velocity. And since velocity is a vector, momentum is a vector. So it's important that you understand that scalars are only a magnitude, but vectors are both magnitude and direction. And you kind of know this intuitively from, if you think about the difference between a force and, say, the mass of an object. You can tell one of those has only a magnitude and the other one has magnitude and direction. Now, if you do have vectors, then there are three kinds of classifications, if you will, that you can have. So you can have what are called free vectors. And a free vector really has no unique line of action in space. It's basically to say that it is not confined to a particular line. An example of this would be if a body moves without rotation, then the movement or the displacement of any point that you choose in the body could be taken as a vector. And that vector would describe equally well the direction and the magnitude of displacement for all other points. Now, another kind is called a sliding vector. Now, a sliding vector has a unique line of application, or excuse me, a unique line of action, but it doesn't have a unique point of application. So this could be, if you think about a force on a body, and we'll talk about this a little bit later. It's something called transmissibility. But if you're talking about a force on a body, if you were to push on one side or pull on the other side along the same line of action, then you could produce the same effect. And so as long as you're on that line, you'll have the same effect on the body. The last one is a fixed vector, and a fixed vector has both a unique line of action and a unique point of application. And this is really when you're dealing with a deformable body. This is important when you're looking at the deformation in the vicinity of the force, so that point of application becomes critical, and then obviously the line of action is going to be preserved as well. All right, so this is just an overview of scalars and vectors, and in the sessions that follow, we're going to get into more detail about how to work with vectors in particular, because that's the important one that we deal with. All right, we will stop there.